All right, today we're going to be doing lesson 2.5. So you're going to need to grab these supplies out of your supply bag that you brought home on Friday. First off, this lesson, it says 2.5 up in the corner, multiplying using the distributive property. You're also going to need one of the lined pieces of paper. I didn't send home graph paper, but we can turn it into graph paper so we can do this. Then you need crayons and a pencil. Other than that, you should be ready to go. I'll wait for a minute while you get supplies, or pause this and come back. All right, are we ready? Let's begin. Move these crayons out of the way. Move the pencil out of the way. Here we go. It says, multiply using the distributive property. Essential question. How can you use the distributive property to multiply a 2-digit number by a 1-digit number? All right, so it says colored pencils, grid paper. We're just going to use lined paper. You can use the distributive property to break apart numbers to make them easier to multiply. The distributive property states that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. Outline a rectangle on the grid to model 6 times 13. All right, so right here, we're going to go 1, 2, 3, 4, 5, 6. And we're going to draw a line. Then we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we're going to draw this line. Okay, so now if we come down on this side, and then we 1, 2, 3, 4, 5, 6. And then we draw our line here. Did you see how Miss Kent checked to make sure she had counted 6 and not more than that? It's okay to do that. Okay. So now I have drawn a rectangle on the grid. One side is 6, the other side is 13. Now it says, part B, think of 13 as 5 plus 8. Break apart the model to show 6 times 5 plus 8. So we're going to leave this side right here as 6. But then, just like the picture shows, we're going to go 1, 2, 3, 4, 5, and draw a line. And that means that I have 5 plus 8. Okay. It says label and shade the smaller rectangle. Use 2 different colors. Okay, so go ahead and pull out your crayons. I'm going to use a green and a pink. Here we go. And I'm going to shade in everything inside that box. And then I'm going to take the box that is 6 and 8 and shade it in as well. Okay. Are we ready? All right. It says, use the distributive property. Find the product of each smaller rectangle represents. Then find the sum of the products. record your answers. Okay. Well, we have 6 times 5. I'm pausing because I want you to answer. What does 6 times 5 equal? 30. 6 times 8, because this line right here is still 6. 1, 2, 3, 4, 5, 6. So 6 times 8. 6 times 8 is 48. Well, 30 plus 48, 8 plus 0 is 8, 4 plus 3 is 7. So 6 times 13 is 78. All right, part C. Model 6 times 13. Again, think of 13 as a different sum. Break apart the model to show 6 times, and I'm going to do 10 and 3. To find the product each smaller rectangle represents. Then find the sum of the products. Record your answers. So what's going on is we tried it one way. We did 5 plus 8. And then I decided to do 10 plus 3. But let's just think for a minute. What other numbers could we have used to make 13? We could have done 7 plus 6, 9 plus 4, 1 plus 12, 2 plus 11. So there's lots of different ones we could have chosen. I chose 10 plus 3 because 10's really easy to multiply by, and so is 3. So here we go. Let's draw another block array. This side is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This side is 13. And then I make my whole block. But I don't want 13. I want to break it down. So 1, 2, 3. This is 10. I'm going to shade it in. I'm going to use violet red this time and yellow green. Here we go. All right, 6 times 3. From my brain, I'm going to write a 6 on that side. Six times 10. Now I'm going to write these multiplication equations. 6 times 3. And yes, I'm waiting for you to answer yourself. If you have to, count the squares. 18. 6 times 10. 60. 18 plus 60 is 78. 78 here, 78 here. We must have done something right. Go ahead and turn the page. All right, it's saying to draw conclusions. Explain how you found the total number of squares in each model in steps B and C. So once again, let's look at those. Okay, B, C. All right. Well, in model B, I divided the first model into smaller block arrays. Period. I used 6 times 5 and 6 times 8 and added the products. Model C, whoops, that's an A, not a C. Model C, I used 6 times 10 and 6 times 3. Giving you a minute to finish up writing your own. You don't have to write mine word for word, especially if you didn't use 6 times 10. Compare the sum of the products in steps B and C with those of your classmates. What can you conclude? Well, whether you did 6 times 5 and 6 times 8, 6 times 10 and 6 times 13, 6 times 9 and 6 times 4, 6 times 2 and 6 times 11, you all would have gotten 78. So the products are all the same. All right, you guys. So now we're going to use what we've learned here. But before we do that, let's just think for a minute. What have we learned? I know it's hard when you're talking to a video screen, but sometimes it helps to think out loud. So I learned that I can take a big number like 13 or 25 or 43 and break it into smaller numbers that are easier for me to use. So if I know that, then any 2-digit number multiplied by 1-digit number should be no big deal for me to figure out. So let's see if we can do the next part. Okay, so the next part, it says think smarter. To find 7 times 23, it is easier to break apart the factor 23 as 20 and 3, or is it easier to make it 15 plus 8? Well, what do you think? +20 plus 3. Because just like when we did 3 times 10, I can use mental math. That's math you do in your head to multiply. Because it's very easy to go 7 times 20 is 140, and 7 times 3 is 21. So 140 plus 21 means that the answer is 161. That wasn't too horrible. All right, so we're actually working with distributive property, and some of you, maybe you don't want to do block arrays. Maybe you'd rather draw base 10 blocks. So we're going to come down here, and we're going to do some problems with some base 10 blocks. Here we go. Use base 10 blocks to model 6 times 3. So we have 6 rows, 1, 2, 3, 4, 5, 6. And in each of those rows, we have 1 10 and 1, 2, 3, 3 ones. So 1 10 and 3 ones equals 13. So if we have 6 rows of that, then we can just count them all up. Ready? So once again, this is 6 times 110. So that 6 times 10 is 60. And then this is 6 times 3 ones. So 6 times 3 is 18, which means 60 plus 18 is 78. Once again, you can choose the way you do this moving forward. These are just 2 examples of how you can break down a multi-step problem. Or not a multi-step problem. That was the wrong word. I'm sorry. How you can do a two-digit multiplication by a one-digit multiplication. That's the better answer. All right, let's go to the next page. Share and show. So once again, when we get to the share and show, this is your chance to pause the video, do the work yourself, and then come back and check your answers. Now, if you get stuck, I'm going to continue on and I'm going to show you the answers for all of this. But I'd really like you to try it on your own first. So pause. Here we go. Model the product on the grid, record the product. So we've got 3 times 13. So we're going to go 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 times 13. I'm going to write a 3 over here, but I don't want to do 3 times 13. Even if I have the answer in my head, I need to model this. So we're using distributive property, and I'm going to go 1, 2, 3. because I know 3 plus 10 equals 13, and those numbers are so much easier. I'm going to pull out my crayons because I love every excuse I get to use my crayons. And I'm going to color in this side with my peach crayon. Doesn't matter what color you chose. 3 times 3 is 9. Doesn't write in there very well. Oh well. And then I'm going to use my crayon here. And I'm going to color in this side with my nice dark blue. And then I'm going to put my crayons away because I don't want to lose them. And I'm already missing one. Here we go. 3 times 3 is 9, plus 3 times 10 is 30. That means that 3 times 13 is 39. How are we doing? Okay, let's do the next one. 5 times 14. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I'm going to write a 5 over here. But then I'm going to break this down into 4 plus 10 because that's easier for me. So 1, 2, 3, 4, 4, 10. Once again, pull out my lovely, awesome crayons. Orange and green are quite Halloween-y. That's not even a good word. And I'm going to color in this one. Five times 4, 20. 5 times 10, 50. All right, I'm going to stop for a second and I'm going to just talk. Let's say you did this on your own like I asked you to, and all of a sudden you don't have 4 and 10. You did 7 and 7. Or you did 8 and 6 because you know those ones. That's fine. As long as your product up here ends up with the same answer as mine, then you did it right. So don't go and fix your block arrays. If you didn't do 4 plus 10, you're fine. Just watch the product. 20 plus 50 equals 70. How are we doing? Let's go on. Okay, so once again, they've broken these into blocks, base 10 blocks. So we've got 1, 2, 3, 4, 5, 6 tens. And we've got 1, 2, 3, 4, 5, 6 groups of 4 ones. So if we put a block around each of these, and underneath them we think 6 times 10 and 6 times 4, we end up with 60 plus 24. 6 times 14 is 84. Five groups. This first one has 5 tens. That's 50. Oh, that's a bad 5. It looks more like a 6. Let me erase that and try again. This over here is 8 ones in groups of 5. So we have 5 times 8 is 40. Well, 50 plus 40 is 90. And then the last one, we have groups of 4, and we have 4 10s, and we have 6 1s. So we have 6 times 4 because it's in groups of 4, and 4 times 10. That's 40 plus 24 equals 64. Whew. How'd we do? All right, so this last part, we're going to read this instructions. It says use grid paper or base 10 blocks to model the product, then record the problem. Well, I don't have base 10 blocks because I'm at home, just like you guys are at home and probably don't have base 10 blocks. So we're going to draw it. I'm going to pull out that line paper, remember I told you to have, and I'm going to write these on there. So here's my lined paper, and I'm going to start with 7 times 12. 7 times 12. And then I'm going to draw 1, 2, 3, 4, 5, 6, 7. And then I'm going to go across, and I'm going to make this pretty long across here, so it's a big block. And I'm not going to worry about drawing the lines in between unless I'm going to have to count those lines. And I'm going to make this 12. And then I'm going to go 2 plus 10. And I now have made my 2 block arrays. This side is 7, this side is 7. So now I have 7 times 2 is 14. 7 times 10 is 70. So 14 plus 70 means that 12 times 7 equals 84. Oops, you can't see my answer. Okay, let's do the next one. I'm going to look at it. It's 5 times 16. So right here, I'm going to write 5 times 16. Now, because I want to save some space on my paper, I'm going to draw a little bit smaller model this time, but it'll work the same. And I'm going to say that the big long side is the 16 and the small side is the 5. So this is the 5, this is the 16. And I'm going to think, well, 6 plus 10 equals 16. 5 times 6, 30. 5 times 10, 50. 30 plus 50 means that 5 times 16 equals 80. So once again, I'm going to pause and I'm going to make you remember that you could have chose other numbers than 6 and 10. As long as your numbers equal 16, you're fine. Maybe you were really smart and you said, I'm going to do 8, because 8 is really easy because I have to do it twice, because 8 plus 8. So once I figure it out once, I figured it out twice, which 5 times 8 is 40. 5 times 8 is 40. 40 plus 40 equals 80. Last one. Our last number is 9 times 13. 9 times 13. Once again, I'm going to draw myself a nice trusty block or rectangle. And I'm going to do 9 on this side. I'm going to do 13 here. So I'm going to 3 plus 10. 9 plus 3, 27. 9 times 3, 27. 9 times 10, 90. See, even Miss Kemp makes mistakes when she talks. 90 plus 27 is 117. So that means that 9 times 13 equals 117. All right, let's go back and put these answers on our page. 7 times 12 is 84. 5 times 16 is 80. 9 times 13 is 117. Problem solving. Let's see. It says, explain how modeling partial products can be used to find the products of greater numbers. Find how partial products can be used to find the products of greater numbers. Well, that's what we've been doing. So this isn't too bad to explain. So I can take the larger number and break it into smaller factors. For example, 6 times 42. 6 times 40 plus 6 times 2 equals the same thing. All right, let's see here. We have a think smarter. Use the distributive property to model the product on the grid. Record the product. 4 times 14. Well, you're going to draw 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then you're going to finish it off. Whoops, went too low there. This side is 4, this side is 4, this side is 14, but we can break it into smaller pieces. Now, we're going to think smarter. We could do 4 plus 10 because that's pretty easy. Or we could do 7 plus 7 because then I only have to multiply once. But then my addition might be tricky. I'm going to let you think for a minute and you decide which way you want to break it apart. Remember, it doesn't have to look like mine in the end as long as you get the same product. Did you decide? Okay, cut it up. Well, not really. Just draw a line through it. Here's mine. I chose to do 4 plus 10. 1, 2, 3, 4, because I didn't want to add 28 plus 28. So I end up with 16, because 4 times 4 is 16, and 40. 56 is your answer. How'd you do? Turn the page. Okay, let's see. Where are we at now? We are here. It says, think smarter. Oh, and look at this. We've got lovely oranges in a crate. Let's see what's happening here. It says, Kylie went to the fruit market. The market sells a wide variety of fruits and vegetables. The picture at the right shows a display of oranges. Write a problem that can be solved using the picture. Write a problem that can be solved using this picture. So we're going to pose a problem. We're going to go and count. 1, 2, 3, 4, 5, 6. 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I do that right? I don't think I counted that right. I did. 6 and 12. But let's see, it says the market sells a wide variety of fruits and vegetables. The picture at the right shows the display of oranges. Well, maybe we want to fill in these last two. So 1, 2. So let's make it, or we could have done 8 and 12. So maybe problem we're posing is 1 display can hold 8 rows of 12 oranges. Look at this, we're writing a story problem. If 2 rows in the display are empty, how many oranges are shown in the display? All right, you guys. There's multiple ways to solve for the answer to this story problem we just wrote. I am going to pause myself. You can pause me as well and solve the problem. Let's see what we end up with. Well, I hope you paused, and if you did, welcome back. Here we go. We have 8 times 12. Well, I know I can take, and on my lovely piece of paper, 8 times 12, draw me a lovely rectangle. I can do 8, I can do 2, and I can do 10, right? You didn't have to solve this way. There are other ways. 8 times 2 is 16. 8 times 10 is 80, which means I now know that 8 plus 12 is 96. But that's not the answer. So now I have to think, okay, I have these rows right here. There's 2 times 12. 2 times 12 equals 24. And yes, that's just a memorized fact for Miss Kent, but if you needed to, you could have done a block array or counted it up or done equal parts or done repeated addition. Either way. Then I'm going to take 96 and I'm going to subtract 24. 2, 7. So, how many oranges are on display? 72 oranges. How we doing? Okay, last one on this page. I hope you're hanging tight. Here we go. Describe how you could change the problem by changing the number of rows of oranges and the number of empty spaces in the picture. Then solve the problem. So it says, describe how you could change the problem by changing the number of rows of oranges and the number of empty spaces. Well, we could have said, well, there's 9 rows full, and we could have added oranges up here. So 9 rows, or I'm sorry, we could have added another row down here. We could have made it a bigger crate. So it would be 9 times 12. Well, if we had 9 rows of 12 oranges, so 9 rows of 12 oranges, 9 rows of 12 oranges. And if 5 rows were empty, now we have a whole new problem. How many oranges are on display? That means we would have 9 minus 5 equals 4. 4 times 12 equals 48 oranges. Whew, we changed the problem and we showed our work. That's all you have to do on these kind of problems. Here we go. We're going to turn the page. All right, you've made it. You are now to the homework page. This page you are going to do on your own. You only have to do the front, but if you'd like to do the back, you're welcome to. When you finish these problems on the front, you're going to answer all of the questions in the Google slide. So you just have to put your answers in the Google slide that is also connected to this assignment. When you have finished with that, I will grade it after you have submitted it. So please make sure you submit your work. Remember, I will grade it by putting a big red slash through a slide if you got the answer wrong and leaving it blank if you got it right. If you got an answer wrong, I suggest going back and trying again. And when you redo it, you can resubmit it for a different grade. Anyway, it's time to get to work.